friend recently came to me and presented me with a challenge to take a number of individual pieces and assemble them into a perfect 3x3 cube with no missing spaces and no parts hanging out of the cube, where all the colors matched up, and that was just a normal, beautiful cube, not quite like what you see here. The thing to me is I found this quite easy to solve, but I asked myself, what is it that makes this hard? Why can someone spend several hours working on this and still not have the solution? What is it that makes this tough? I think the first part of the answer is that the number of different ways that these pieces can be assembled is too much for anyone to hold in their head. And after a short while, even the different combinations you've tried, things that you've maybe spent several minutes working on, trying in different combinations, and then realized these two pieces don't go together at all. But 20 minutes later, an hour later, you've forgotten that you even tested those two pieces, what pieces they were, and you're back trying them again. It's a confounding and confusing situation. So what you have to realize is that this is not just a logic problem, but a logic problem that, as they say, breaks the crow. I don't know if you've heard the story about multiple men that walk into the forest and the crows stay hidden as long as 2 out of 3 of the men come back out, because they know there's still one man hidden in the forest. But once there get to be a certain number of men, something like 5, if 4 of them come out of the forest, the crows feel safe to go back into the field because they don't realize that there's another man still left in the forest. They can't count, and they're unable to grasp more than something like 4 things at one time. The same is true here. There's so many combinations and so many possibilities. No one is able to keep them straight and remember what you've tried, what works, what doesn't work. So I think it's really important to realize that this is the key part of this challenge, that obviously you have to fit the blocks into a logical assembly without breaking them off and re-gluing them or doing anything like that, replacing the pieces, leaving pieces out, putting your own pieces in. There's all kinds of combinations. Building something other than a 3x3 cube. There's all sorts of things you could do, but you have to say, no, I'm going to simply assemble these into a cube, and my problem is not so much how do I assemble them into a cube, but how do I keep track of what I've done, what I've verified, and what I've not tested. I think the first step is to label all of the cubes, all of the blocks, not cubes, and you've seen that I've done that here. Just little sticky notes that put a number on them and allow me to put together a list of the things that I've tried. The next step, I think, is to figure out, is this even possible? Is what I'm trying to do conceivable? And I think there's certainly several different things that several different ways it might not be possible. First thing is, are there the right number of blocks? Obviously there are whole blocks here and half blocks. Do they count up to a 3x3, that is 27 complete blocks? And when you add them all up, sure enough, you have 27. Now the question is, do you have the right number of brown pieces, and do you have the right number of yellow pieces? Because in a 27 block cube, you obviously have 14 of one color and 13 of the other. And as we count, we see that there are 14 yellow and 13 complete brown. Now, thinking about that a little bit, we realize that the center of the cube then has to be brown, and the corners have to be yellow. This is a clue that will help us go through. So we write this down. Center is brown, corners are yellow. That eliminates some things we might try, but now we know they're false. They won't work. Now, the next part is, I think, probably the hardest part. There are many steps you could go through and try to figure out just what is possible and what is not. But what sometimes will yield very good fruit, give you a much quicker path to deciding what you can and can't do, is to look for unique parts that will only fit in the solution in one way. I have no general rules to tell you how you do this. You generally have to look for something that is unique or has a special requirement that can only be met in certain ways. But that's not a very specific answer. I think not a very specific guidance in how to do it. When you look at piece number 1, I think you will see that it has some unique properties. It has 2 half pieces, and one of the half pieces is connected not on the end, but in the middle. And this middle piece, this middle half piece, presents some special challenges when trying to connect to it. When you try to connect using pieces such as pieces 4 and 5, any way you connect to that center yellow piece will actually extend out beyond a 3x3 cube. So 1 cannot connect with 4 and 5. That's out. And I'm talking about for that center half piece. The only other 2 pieces that have a half piece that's available are 2 and 3. And 2 and 3 give a number of different positions that they can go together. If we look at 1 and 2, there are 4 ways that 1 and 2 will go together as you rotate 2 on top of 1, on top of that center piece. In none of these positions, however, will 2 fit with 4, 5, or 6. Any way of trying to put 4, 5, and 6 together with 2 leads to a problem, leads to the number 2 block pushing the 4, 5, or 6 out beyond what is possible in a 3x3 cube. It's too big. The other option is that 2 and 3 actually fit together and sit up on 1. And these 2 do. 2 and 3 will fit nicely. They'll sit up on top of 1. And there's 4 different positions that they can be in. So we're going to set that aside, and we're going to make a note that 1, 2, and 3 will fit together in 4 different positions. Now, when we look at pieces 1 and 3, there are 4 different ways that 1 and 3 can go together, same as 1 and 2. However, in none of these 4 positions will 3 fit with 2. It's kind of an interesting situation that when 2 is sitting on top of 1 and 3 is connected to it, there's no problem. But when 3 is sitting on top of 1, 2 cannot connect to it. When it does, it always violates the 3x3 block boundary. 3 and 7 will go together and sit on top, but then you will need 2 to connect to the other half block of 1. Now, once you try to put that half block down in 1, there's only one position that number 2 will go in, but number 2, once you put it there, nothing will connect to it because of that half brown block. So this is another connection that is automatically out. So let's look and see what we've established so far. We've been able to take several of the blocks and say, look, there are only certain combinations that will work with piece number 1 and the center yellow block that comes out of it. And we've looked at every single piece we have, and no matter what you do, only 2 or 3 can sit up on top of that middle yellow piece out of 1. Once you know that, and you go the next step further, we've also identified that only way that works is if 2 is sitting up on top of 1. That all the different ways of putting 3 on top of 1 and rearranging with other pieces yields to contradictions, to conclusions that do not allow you to go any further. Positions, block positions, that violate the 3 by 3 cube you're trying to build. The only thing that works is to put 1, 2, and 3 together with 2 sitting up on top of that middle block of 1. Now this is really important. First of all, we know what we're talking about because our blocks are labeled. And number 2, we've been able to identify a certain relationship by writing down what our steps are. Even if I had labeled all these blocks, if I was just trying to hold this in my head, I probably wouldn't be able to do it. And you listening to me explain it probably can't follow quite either. It's just a little too abstract, a little too hard to hold together how these are. Even, and part of the problem is you aren't holding these blocks in your hand. But even holding them in your hand, you could probably follow along what I'm doing, but you wouldn't know that I had really fleshed out all of the different possibilities. You could only do that if you yourself put the blocks together and then write down what it is you're doing and what you've discovered. Any other way is just going to leave you in a confused state of saying, maybe, I'm not sure, I don't know, I think I've tried this, but have I? Are there other possibilities? You just don't know unless you realize that your ability to retain the number of different positions you've tried is limited, and that you have some way of breaking the crow, of being able to get beyond that first level perceptual limitation you have, of drawing conclusions, of writing them down, and then building on earlier conclusions with further testing. Alright, so let's go on. We've decided 1, 2, and 3 can go together, but now we've got this little end block on 1, this other half block. And there are not very many other possibilities, once 2 and 3 are out of the way, to connect to this. As a matter of fact, only 4 and 5 have yellow half blocks that could possibly connect up to it. So let's try number 1 and number 5. When we do, 2 and 3 will go together, and they will go together in only one way. Every other block, every other position of them violates the 3 by 3 cube. But when we do it this way, there's simply nothing else that will connect to 5. That half brown block just won't fit anywhere. So, we go back, we put 4 on, connect it to position 1, and looky there. There's no way to do this. 4 will not connect to 1 on that end piece in any way that does not violate the 3 by 3 cube. So, what have we decided? What we know that now is that given the puzzle as it's been presented, i.e. you're going to form a perfect 3 by 3 cube with all blocks being of the same color in the same region, that is, half blocks line up with the same color half block, and without making any changes to these blocks in shape or form, that there literally is no way to put this together into a perfect cube. Now there's other puzzles that are possible with this, but this particular puzzle is not possible, at least not as I've stated it. So, what have we learned from this? In order to reach a conclusion, we have to know what the real problem is and what our own limitations are. In this particular case, if we tried to determine that it's not possible to build a 3 by 3 by 3 perfect cube from the given blocks without modifying them and we wanted to do that simply by trial and error and memorization, we would probably never get there. It's simply, there are too many combinations, there are too many things that could go wrong, and it's just too much to hold in your head all at one time. Now, I might have made an error in my reasoning, but because I wrote down my steps, because I labeled the blocks, I'm able to recheck my solution to the problem and, given enough time, find any mistakes that I might have made. It's normally assumed in games of this type that to take a methodical approach like I have of labeling the blocks and making a list of what conclusions I've reached is a little bit cheating or making it too easy, because that's the whole point of it, right? How much insight you have, how good is your memorization, how quickly can you find the solution. The key here is to realize when the problem simply is beyond what you can hold in memory at any one time, which is what makes it such an interesting problem of applied epistemology.